I thought I would do a video of my build of the German RoeTest tube tester that I finally finished a couple weeks ago. I've just been spending about a couple weeks testing vacuum tubes and enjoying how awesome this tube tester is. I mean, words cannot explain how much this tube tester can test. The parameters you can test for the type of tests that you can perform with it are endless. And some of the things that you can do with it that's unique that you cannot do with any other tube tester, in which I think it makes it a candidate for one of the tube testers out there, in my opinion. But before we dive into its features and what it can do and what kind of testings you can perform with it, I'd like to take a moment and show how I did my build. So this tube tester is created by a gentleman named Helmut I believe in Germany, and you buy the PCB, the chassis, the power transformer, which is, there's two different toroidal transformers. There's one main power transformer and one for the auxiliary voltages and some other hard to find parts, but then you got to get the entire BOM yourself on Mauser or whatever site you prefer as your primary source. And it's quite a bit. The shopping list is pretty big. I mean, I would rate this build as far as easy, medium, difficult on extremely difficult. And I'm not just saying that to scare anyone that wants to build this, but it's like building a computer to me. And I've done quite a bit of soldering over the years and building stuff. So there are many cards inside of this. There are relay cards. There's anode, G1, G2, G3, heater, 600 volt cards. There's the main processor card and the motherboard, and then all the 10 or 11, I believe, relay cards that have several relays. And that is how RoeTest, using the software, can actually switch all the pins on the vacuum tubes automatically. So it's somewhere around, if I believe reading at 6,400 to 500 solder points. I went through easily 2 reels of solder, and that's not including these socket boxes that you see over here, or the header box or the calibration box. This is just the RoeTest itself, and that is exactly why I would say this is scaled to be an advanced project. But boy, what an awesome tube tester it is once you get it done. So without further ado, here are the socket boxes that I made for my unit. So it is suggested by Helmut that you make individual socket boxes for your header, so you can actually put, like, let's say a compactron socket or an octal or novel or loctal or whatever on here. And on his manual, he utilizes plastic socket boxes, so the enclosures are easy to drill and you can make as many as you want. I didn't want to have 20 different socket boxes laying around and just taking space, so I decided to make my socket boxes out of steel. So these are steel chassis boxes, and you can see that this has pretty much all of the sockets that you would see like on a Hickok or something over there, from 7-pin miniature, novel, loctal, octal, 6-pin, 5-pin, 4-pin, 7-pin, whatnot. And this one box here basically takes care of most of my socket needs as far as vacuum tubes that I use in my designs. And then I have a secondary box here that has the Septar and the other bases for transmitting tubes, in which I plan to add some more to. For now I have these two, but I will add this jumbo style 4-pin connectors. Sometime this week I'd have to drill and tap this wide clearance for the socket to be able to get there. So I decided to use this style of Jones connector, US made Jones connectors, that I was able to get at Apex Electronics here in LA. And I just like these because of the way that they're mounted, and it only goes in one way, and I was able to get a handful of them for my socket boxes. Here is calibration box. Calibration with RoeTest is a pretty straightforward thing to do. You could either use single resistor method, which I was trying to do at first, but I decided it was a headache and this was the way to go. There's great write-up from Helmut on how to make the calibration box, and the software actually has a calibration assistant that you use to calibrate the whole unit. So this will essentially hook up right here, clicks in, and then your voltmeter's negative will go here. You measure voltage or current, and then you can do a compensation for losses on the sockets for the heater with the switch. And this has all of the 1% 10 to 25 watt power resistors in it that mimic the current draw of a real circuit for the calibration. So this is the way to go. Here you can see my anode and grid caps that I made, which goes over here. As you can see, it says top, so that would go obviously to the top of the tube. And then 9 set side, that would be like if a tube has like a grid on the side, like a 100 TH or something that has a top cap and a side cap. And yeah, I decided to finish everything in this mocha color. No particular reason, I just had that spray paint laying around. I used on one project and I said, what the hell, let me use it on this, and it turned out great. So I'd like to show the functions of the software a little bit. This is for all those people out there that know about this or just found out about it and they want to be inspired and, you know, find out if it's right for them. I say guaranteed 100% it's right for them. It's definitely not cheap to build. I mean, I would say with the costs of buying the PC boards, all the PC boards, all the transformers, the hard to get parts, the chassis, and the firmware from Helmut, plus my own bomb that kept growing and growing. I kept going back, ordering more stuff, thinking I was final, and then I would find I need more stuff. I would say I've been in it maybe 3,000, maybe a little bit more, a little less. I still have to tally it up. But considering how much these Hickoks that are kind of like known to be one of the best tube testers that are out there, not this particular model, but the Hickok family of the transconductance testers. I mean, these have nothing on the RoeTest. If I was to compare this tube tester to this, it would be like comparing a bicycle to a Ferrari. It would be literally pointless, because this is a very crude tester. If the calibration is right, you might get a reading of correct transconductance, essentially, but you know, you're constantly adjusting line voltage, making sure it's dead center, testing, whatnot, and nothing is timed. It all depends on how long you let it warm up, and there's definitely sag, and these were designed for 115 volts mains, not 120, so there's a lot of weird finicky things about it. But the RoeTest, you know, all of the voltages internally, your anode G1, G2, G3, your heater, everything's calibrated, voltage regulated down to 0.000 when you're doing the calibration. So all of your voltage readings, your current sensing, voltage sensing circuits are like computerized. It's hardware talking to the software. Software has virtual instruments, as you can see, and the virtual instruments essentially, as it's running the test, show you what's happening, like the anode voltage is rising up, the current, whatnot. And then there is your logger that logs what's happening, and then you get the data essentially show up in a window. So this has been a great tool. My first impression, I was blown away. In the next few days after I finished this build, I started curve tracing tubes, which I have another curve tracer that's more rudimentary and simple. It's a Russian one. And yeah, that's also garbage comparing to this. I mean, you can't really match tubes with it. It's like you would have to print it out and like overlay. Like if you're trying to match tubes for different operating points, making sure the entire operating points of different grid voltages all match, it's pointless to use the one that I'm referring to right now. But with this, you have the easy match system 1 and 2 in it to match stuff, and you can also manually do it depending on what you're trying to match to, whether it's the mu of the tube, the transconductance of the tube, or matching by plate current. So this makes it very simple. Also, I design amplifiers with transmitting tubes. For instance, there's an 811 right there, the tall boy. And the data sheets usually show Class C telephony and like radio, you know, applications for the tubes. There's usually not an audio frequency data. If there is an audio frequency example and data on the data sheet from the manufacturer of the tube, they will show some ridiculous ratings like 2000 volts or something, and you know, output transformers that are absolutely unobtainable and has to be custom made and are really high impedances and whatnot. So sometimes I want to curve trace a tube like that at a voltage like 600 volts and see what kind of like design I can do with that, and what the swing looks like, and how linear the tube is at those voltages. So this is where this comes into play majorly. So without further ado, let's do some testing. I'll just test that 811 I have sitting here right now and show you guys how this works. So the socket box is really nice. It's all steel. It's completely shielded. All the wiring is extremely low resistance, thick wiring, so there are no losses. Keep in mind, this has to be kept very short from the PC board under the chassis, because even milliohms of resistance during the calibration compensation matters. So that's why he suggests that you keep it short. I added these handles myself for carrying it around when I need to lift it. And I kind of utilize it as a side rail for sliding this forward, and I use these zip tie sticky pads as like bumpers, and it ends up working really well. As you can see, I just snapped it in, and this is not going anywhere, and it's in there. So let's go ahead and on the computer and load up the data for this tube so you can see. So come right here. By the way, this software, you can choose the language. The native language for it is German, obviously, but you can, when you install it, you can choose what language, and I have it on English, obviously. So 811 is the tube I typed previously to recording this video. This is the 811 tube, not the A version, which has the cooling U channels added. So I'm just gonna load it up, and it says it's a VT217 positive grid voltage, checking the tube for data consistency. Okay, keep in mind, you can come over here for any data that's already in the database and alter the parameters of the tube. So if you want to lower its maximum ratings, you can manually, like here it says voltage anode 1500. Obviously the RoeTest only goes up to 600, but this is just showing its, you know, ratings and whatnot, and what you want to test it at, and other info you can add and things like that. So I'm just going to close that because I'm not going to modify this, and get the tube started on here. So when you put the tube on the RoeTest, let's see, the two fat go right here. When you put the tube on the RoeTest and hit start, the first thing that RoeTest does is a soft start of the filament. So here's the anode cap, and it slowly ramps up the filament voltage. And here's the top. So now we're all connected, so the tube doesn't get a filament jolt. So I'm ready to do a static test. I hit static test. Hear the relay click in, and then the filament soft start, as you can see. And what happens is this dialog comes up, and I preset my settings for 30-second of warm-up time, but you can change that. I found that 30 seconds for most tube gets them to a place where it will give you a constant meaningful reading. As you can see, there's 600 volts on the plate, 20 volts positive grid voltage, which is drawing around 6.2 milliamp on the grid. The anode's at 55 milliamp, and the fan just kicked in on the RoeTest, and it just finished testing. So now you can see here, let's get my mouse somewhere you can see it. It says nominal plate current is 70 milliamps. We tested 55.61 on this tube, so we're looking at 79% out of 100, obviously. And then the transconductance 3750 micromoles, milliamp over volts. So I would say that's a tube that's getting weaker. It's still good, obviously, test screen, but it's getting weaker. So let's test another tube with it. So let's change it up to a octal base. So here's another tube. This is a 6BG6, which is very similar to an 807 and a 6L6 tube, and it has a top cap, it has higher ratings, and an octal base. So I'm going to key it in, and then it uses this type of cap, medium size, and here's the top. Let's go to RoeTest and do load tube data 6BG6, enter. 6BG6, 6BG6G, GA, GT, you can choose what kind. I'm just going to do G. Loads it up, and then I'm going to do static test. This window on the bottom shows the plate current of the tube rising. Once it plateaus on top, that's when you know the tube is actually fully warmed up to then do a sample measurement, which is going to be your end result. But as you can see, it's under full voltage, 250 on the G1 and G2. There's almost 70 milliamps on the anode, and look, plate current steady, 30-second, and it's gonna test. And you can see the logger quickly logging all the internal happenings. Over here is your cathode current, your grid power, your power dissipation, and your screen G2 power, and then just the power of the heater. So these meters are really cool So here we go. So this one's a little bit more in depth. It's a pentode, but you can see that 75 milliamp is a good tube. We tested 69.44, so we're 93 out of 100. Screen current nominal is 4 milliamp. We tested 2.133, so the screens are basically good. Other stuff like the mu of the tube, which is 142.9, you know, and measured plate current, and then you can see plate resistance and other stuff like that below it. So, well, my camera was out of range, but yeah, I mean, this tube is really cool for stuff like that. On some of the tubes you can check for vacuum, like the condition of the tube. Why does my phone not want to focus? And then I'm gonna do a follow-up video. This video is already getting kind of long. It's about 20 minutes, but yeah, you can do other stuff like curve trace, which I'm going to do in another video because it's a lengthy process. So I'm gonna hit escape and cancel. You can do batches of tube testing, which is so awesome. I've been doing that with a bunch of 6 AU6s for a project I'm working on that I need to gain match tubes. So essentially, I hit the batch start, put the tube in, records it, pops a window, I save the PDF, the result, and then I remove the tube and it says insert the next one. I insert it, automatically detects it and starts testing it. And then boom, the dialog prompts, I save the PDF, next one, next one, next one. And then I can pull all of them up, look at the data, and grab the ones that gain match and go from there. But this wraps up this first impression video of my RoeTest build. For any of you that are out there that are doubting whether you can afford it or whether it's going to give you, you know, everything that you need, I say get it. It's worth every penny. I'm gonna sell this and my Philco version of the top of the line Hickok, which is not obviously the 600A, but I'm going to be selling those in the next couple weeks, toss them on eBay because I will no longer have any use after having this baby. So, but yeah, if you haven't subscribed to my channel, please go ahead and do, and like, and whatever. I'd like to hear your input, and I should be submitting some videos and photos to Helmut. He puts it on his website. Everyone who's built one basically sends him a build report, and it's kind of like his testimonial system for his tube tester. And again, I want to thank Helmut for being a great help. I mean, building this, I had a lot of questions about certain stuff that I ran into problem with, which a lot of it was dumb things I did. I don't want to get into it because it's going to make this video even longer, but he is great help. So as far as support goes, not even a minute passed where he wasn't there, you know, helping me with questions I have. So go ahead and do it, and I hope you guys have a great week.